Okay, in this video I'm going to continue on with exercise 5b of the book Fundamental Applied Mathematics. We're on page 130 and the question is 3. It reads, a barman slides a pint glass of beer along a counter so it leaves his hand with a speed of 3.5 meters per second. The mass of the full glass is 1 kilogram and the coefficient of friction between the glass and the counter is 1/7. We're asked initially to find the frictional force. So we need to draw a free body diagram of the motion. So I'm going to say this here is my glass. And at this stage I think it's fair enough to say that if you're at least watching my videos, you understand what I mean by Newton's third law. So the other thing I'd like you to watch, just if you don't, is my video on the massless rope. I think that's important. That's actually vitally important. And also watch my video on Newton's third law. The two of those go very well together, hand in hand. And if you understand those, you're absolutely fine. So at this stage I'm going to assume that people understand it and I won't be so rigorous. So let's work out this is the pint, the glass will say its mass is equal to 1 kilogram. So the force on the glass in air is just going to be its weight vector. So we could draw the weight vector here, which is equal to mg, so it just turns out to be g. We're to find the gravity vector in the following way. It's equal to g j hat like so. So it's negative g j hat like that, because the mass is equal to 1 kilogram. We know by Newton's third law, every action has an equal but opposite reaction. So the force of the earth on the glass will be in this direction. It'll have a magnitude, I'm going to call it n. Its magnitude is going to be g, so it's opposite in direction, and the same magnitude, so it's going in the j hat direction. We're going to have a frictional force, so I'm going to say that the frictional force is in this direction here, like so. And we know that the frictional force is equal to the coefficient of friction times the normal force. Alright, and we're also told that it has a velocity in this direction, I'm going to call it, of 3.5 meters per second. And that's going to be in the I hat direction. Alright, so what can we do here? Well, we can work out, of course, the frictional force. So we can say the frictional force, there's a vector, and so is that, is equal to the mass, the friction force equal coefficient of friction, which was a seventh, times the magnitude of the normal force, which was g, so it's equal to g over 7 in a negative I hat direction. Alright, so I can just change this and say the frictional force is equal to negative g over 7 I hat. Like that. Alright, so we're doing reasonably well so far. The next thing we need to do is work out the overall effect of all these forces. Ignore the velocity for the moment. So from Newton's second law, we know that the sum of the forces on the glass is equal to the mass of the glass times the acceleration of the glass. So let's get the sum of the forces. So the sum of the forces are, on the glass, are equal to negative g over 7 I hat. Negative g over 7 I hat. There doesn't seem to be anything in the positive I hat direction. It's going to be g in the j hat direction and negative g in the j hat direction. And that's going to be equal to the mass of the glass times the acceleration of the glass. Alright, so these two just cancel out and we get that the acceleration of the glass is equal to minus g over 7m of the glass. Alright, now does that make sense? And I'm going to say it does, because it's going to be, excuse me, I need to give it a direction. It's in the negative I hat direction. So what we're saying here is that we have a deceleration. It's going in the positive I direction and there's a force acting on it in the negative I direction at minus g over 7m I hat. Like that, and that's equal to a. Now, you need to say to yourself, does it make sense? And yes, it does, because we have nothing forcing it or pushing it to the, we'll say, the positive I direction or the right. We only have something slowing it down. So it makes perfect sense that this acceleration is in that direction. Now here comes your knowledge of Newton's first law. He said that a body will stay at v equals constant, or constant velocity, or at v equals 0, unless acted on by unless there exists, that's the symbol for there exists a force. Alright? And that implies, of course, if there's a force, there must be an acceleration. Okay? So turn that statement around. If there's an acceleration, there is a force. Like that. Alright? So let's see what that means. If we've worked out that there is an acceleration, therefore there must be a force. So let's find it out. So we have the sum of the forces is equal to the mass times the acceleration of the glass. Okay? We know that the mass of the glass is equal to 1. We know the acceleration of the glass is equal to minus g over 7, and the mass of the glass is 1 again, so it's just minus g over 7. Sum of the forces like that. So F is equal to minus g over 7 newtons. Like so. And that's going to be in the I hat direction. So let's just check. We're asked to find the frictional force, we're asked to find the deceleration of the glass, and finally the distance the glass will travel before coming to rest. Alright? So let's just use our accelerated linear motion concepts of UVAST and apply them. So we have U, V, A, S, T. It begins at 3.5. It is moving initially in this direction, but it's being decelerated in this direction, so I'm going to call my deceleration g over 7, because of course the mass is equal to 1. It's coming to rest, so let's just use v squared is equal to u squared plus 2as. So we have 0 squared is equal to 3.5 to be squared minus 2g over 7 times s. So we have 7 times 3.5 to be squared, that's a negative, times 2 over 2g is equal to the s vector. So let's just put that into the calculator and see what we get. So we have 3.5 to be squared, multiplied by 7, divided by 2, divided by 9.81, and we get an answer of 4.37, or 4.4. S equal to minus 4.4 I hat. Oh, minus, why is it minus? Am I missing something there? Actually, that's a minus number as well. So 4.4 in the positive I hat direction. And that, of course, is in meters. So let's just check that at the back of the book and see how well we did. So it's 5b, question 3. And 1.4 newtons was the, let me see, 5b, question 3. So 4.4, that's correct. The deceleration, let's find out what the deceleration was. It's g over 7, so it's 9.8 divided by 7. And that is 1.4, and that is correct. So thanks for watching. Please pass it on to your friends and subscribe to my channel.